You have some competitors engaging in a particular activity, and then the results that they get indicate which ones are better at that activity. So a simple example would be a bunch of people that run from point A to point B. If they all start at the same time, the ones that get to point B sooner are better, right? If you want to understand why the runners perform the way that they did, it can get quite complicated. So complicated, in fact, that the trainers of world-class runners make a lot of money. The reason why they're considered valuable is just based on their ability to understand why some runners are better than other runners. That's it. And because there are so many factors at play, it's near impossible to account for each one, let alone understand how different parameters in the life of an athlete interact with each other. Our brain can only keep track of a few variables at a time, like 2 or 3. So in a conscious way, which makes experience such a valuable thing among humans, because if you hold an interest for a long time in your mind consciously, you basically ingrain your subconscious with that interest, and then you're able to accurately predict the outcome of hundreds, maybe even thousands of variables, but you're not really able to articulate how you do it. You just know that you can do it. So let's try to prove that you can have a robot that is just as effective at training an athlete as a human, and it needs zero experience, although it would have to conduct an ongoing competitive analysis, but the survival resources required are orders of magnitude lower. I mean, just think of how much you have to pay a trainer, or is it a coach? Okay, they don't make that much, but still, I think we can bring that carbon footprint down for this job, and we can achieve the same outcome, if not better. And the way to do that is to explicitly account for all the factors at play. Now, when I say all the factors, what I really mean is, for the purposes of a practical, realistic analysis that we can do today, is most of the factors, or the factors that are most important, the ones that have a fairly obvious contribution to the outcome. Because, like I said earlier, if you have enough computing resources and the right logical models, you can establish connections between all elemental particles in the universe. But we have to draw the line somewhere. Like, we're not going to look at the altitudes of the place where the athlete's grandparents lived, but we're going to look at their food intake, right? We're not going to account for the time of day when the animals that the athlete eats were sacrificed, but we will be noting down how much calories he gets, whether those calories come from plants or animal sources, the macronutrient group, the feeding schedule, stuff like that. Let's see, other examples might be related to how they train. Then you have things about their state of mind and so forth. So, since you know how each runner performed in the race, after the race you have the results, right? So you can use this type of analysis that I'll show you here to understand how certain features or certain configurations of features influence the outcome. And then if you want to join the race as a new competitor, you are aware of the effort needed, first of all, and you know what to focus on. Okay, so let's do a concrete example with a real-world utility. EOS, or EOSIO, is a blockchain network. If you don't know what a blockchain network is, but you understood the concept of the recursive statement that I started this video with, then don't worry about it. I'll explain the basics and you'll understand it. But if you don't know what a blockchain is, and you also didn't get how I know you understand English is a recursive statement, well then I really don't know what to tell you. I mean, you can keep watching, but probably better off developing some physical skills like sports, or you might do well in arts, or you might be a shepherd, you know? Yeah. Anyway, blockchain. It's a data structure that optimizes data integrity, and this is why most digital currencies use it as their backbone. Since Bitcoin showed up, lots of other exchange tokens came out with different implementations of data structures and consensus protocols, each one hoping to become the dominant means of exchanging value. Well, maybe not every crypto project had that ambition, because some of them were just downright scams, but this is the ideal, right? This is the fantasy that altcoin founders fall asleep to. This is their go-to happy place. And frankly, it's a pretty cool fantasy to have, because taking the economy away from the territorial administrations is no small feat. Especially with countries being the way that they are, such barbaric power structures. I would say that a new world order is due, but so far no digital token achieved supremacy. What we do have is a fairly definitive list of requirements that the ultimate coin should meet. So let me tell you what those are. It should be immutable, meaning that no authority should be able to interfere with its core operating structure, and Bitcoin has that. Some say that it needs to be transparent, with traceable transactions, but I'm not entirely sure that's what we need, because, I mean, as long as it's secure, people will pay for things that they feel they're getting value in return. And I don't see the point in others getting involved and looking at the ledger, seeing who bought what and in what amount. You can maybe include some escrow and refund capabilities through various smart contracts, but I'm not in favor of complete transparency. Anyway, Bitcoin is a completely transparent blockchain and anyone can explore it. There is one requirement though that Bitcoin fails to meet, and that has to do with transaction speed. And you can see how this plays a critical role in mainstream adoption, because nobody wants to spend 10 minutes with the groceries in their hands at the supermarket waiting for their transactions to be validated. And the reason it takes so long with Bitcoin is the proof of work consensus protocol. It takes an average of 10 minutes for miners to produce a block, because they have to compete among each other to find this hash key, and the block needs to be propagated across the nodes. It's a whole thing. And as I said, it makes for a very secure way of storing value, volatile as it may be, but sending and receiving Bitcoin takes a while. That's where other coins felt like they could swoop in and provide a better solution. Most of the cryptocurrencies out there that provide short transaction times do so at the expense of decentralization though. So let's talk about EOS, because EOS does just that. The way this coin processes transaction quickly is by only allowing a bunch of selected nodes to publish blockchain data. So rather than allowing everyone to compete for publishing blocks, the consensus is called delegated proof of stake. So proof of stake means that you as a token holder have a vested interest in growing or at least maintaining the value of your tokens, right? So the more tokens you have, the more likely you are to want the underlying processes of that financial system to work. So delegated proof of stake means that you practically get to vote as a token holder on who validates transaction, and the more tokens you have, the more your vote weighs in the election process. Now, if you want to be the one validating the transactions, aka a block producer, that's what they're called, because they literally create and publish blocks on the chain. So block producers are chosen from a list of candidates. If you want to be one, you have to submit your candidacy. The reason someone might want to be a block producer is because it is profitable. The entire system has a built-in controlled inflation mechanism, meaning that a certain amount of tokens is generated to cover the fees for block producers. Currently, that's about $2,000 a day. Now, obviously, there are other advantages, but it's not just the money, but the money is a general incentive for everyone. So let's see what it would take for you or me or anyone to be voted in as a block producer. You basically need to convince the community that you deserve the position. And so the community is made up of token holders who want the block producers to behave in a way that the network is stable and even growing. And the voting system is a bit different in the sense that you don't just get to vote for one candidate. You can pick up to 30 of them, and then the first 21, so with the most votes, they get to be active block producers. But if you're in the top 91 block producers, you might still get to validate a transaction now and then, but you don't make as much as the top guys. So let's get to the gosh darn competitive analysis to see if it's even worth being a block producer these days. We'll use Jupyter Notebook, and I'll put a link to it in the description. Let's start by installing Python library for interacting with the API for the mainnet. Just like with any blockchain, you use a virtual machine to run a full node. I mean, with any blockchain, yes, if you use Ethereum, that has a virtual machine. This one also has one, and it has a set of commands that you can use locally on your own node to call different things on the network, or you can make that virtual machine available through RPC calls. So if you're on a full node, you can have an API. This library was developed by an ex-block producer that was recently absorbed by the company, the core company that is developing EOS, which is Block 1. So we import the command line tool from the library, and let's get pandas as well, because we'll build a data frame. Now, let's call the API and get the top 100 block producers, store it in this variable, and let's have a look at the format. So we have a few fields. This is the account name, basically the unique identifier of the account, and every wallet needs to have this. Then we have total votes. This is particularly important for our analysis because it shows how much money is being staked on their candidacy by the voters. And the decimal point is wrong. It should be 4 places to the left. But it's not taking into account the vote degradation, which is another inbuilt mechanism by which older votes count less than new votes. Anyway, this is another useful field, which is the website. And this is why it's useful. You can go to any block producer's candidate website, and they have this JSON file that provides additional info about them, such as their location, how many nodes they're running, links to their social platforms, and so on. You can basically get this in a structured way. So you can get some more information about them in a structured way. So let's make a data frame for the candidates with the account name, number of votes, and let's call this EOS. So then the website, and now let's populate it. So we get the account name, the total EOS and website from the initial request that we made to the API, and we get the number of nodes and the location from the JSON file. case we're unable to access the file for whatever reason, let's just put in a 0 in the location column and default to one node. So okay, if we look at the data frame now, we can see that the data is there, so we already know some stuff about these producers. We know how well they're doing, we know where they're from, and we can in theory do a comparative analysis just based on these few attributes that we have and see if there are any distinguishing patterns. So we can see that the top 23 block producers all have the location available, for example. In their JSON file, further down the chart, there are a few missing, but we might say, generally speaking, voters prefer candidates that make their location known. The number of nodes doesn't seem to matter so at first glance, but yeah, this is how you would eyeball the comparative analysis. We're gonna do it a little bit more scientific though, and for that we'll need to add some more features, and we need to consider two aspects. Number one, what are the types of things that voters are likely to care about? And number two, what features can we actually extract? Because not all information is available, especially if you're working with limited intelligence inside the skull. So let's base our list of features on survival value, which is always advised. I mean, that's what I'm advising everyone to do. Steer close to the survival value when you're performing competitive analysis, because otherwise it's easy to get lost in abstraction. So what do token holders want? Well, they want to, at least, like I said, preserve the value of their tokens and potentially even increase it. So the value of the EOS coin compared to Bitcoin, or say the United States dollar, should stay the same or go up. There are a bunch of factors influencing the price of an asset on the market, but generally when the demand increases, so does the price. It's also the other way around, right? So to a certain extent, when the price increases, so does the demand, because people like to be on the ascendant trend of value. So how do the block producers contribute to the value of the token? Well, like I said, they support the entire computing infrastructure. All transactions and smart contracts go through them. So for once, they need to be able to do that, to bear that computational load. The technical infrastructure might be an important factor. And if we look at some block producer websites, we see that they indeed mention what type of node setup they're rocking. And we can break down the technical infrastructure into a few separate components just to make it easier to evaluate. Number of CPU cores for bare metal servers, which will be the same as vCPUs in the cloud. Total RAM, storage space, and connection speed. Actually, let's not use connection speed. Another technical aspect that contributes to the performance of the network, actually it's not that technical as much as it is physical. I don't know, it's a factor. Geographic diversity. So since EOS aims to reach all the corners of the world and get massive mainstream adoption, that's the goal for them. If the block producers are more or less evenly distributed across the planet, that would, technically speaking, optimize the overall performance of the network and provide the end users with a better experience. So let's add that to our list of features. What else? Well, different countries have different views when it comes to cryptocurrencies in general, and most importantly, they have different regulations. So from places like Morocco, Bolivia, or Egypt that impose a downright ban on the use of digital coins, all the way to island nations like Cayman, for example, where anything goes. So the friendliness of each jurisdiction varies, and it can play a big role in the security of the network, because you want to avoid a scenario where a government takes control of a block producer's validation node. Let's see, what else can we add here? So you've seen how much block producers make, an average of $2,000 a day. Nowadays, a few months ago, they used to make twice as much, but the coin went down. And just running the server with the current network activity would cost what they earn in a day. They would pay that for a month. So what are they doing with the rest of the money? Ideally, they would do something that would benefit the network, like develop some distributed application to provide value to users, make some centralized or distributed fintech products to make it easier for people to adopt the coin, stuff like wallets, exchanges. Another thing they could do is to promote the network, either create content or partake in crypto evangelism, organize events for the community, maybe conduct some hackathons, get some smart contracts on the network that way. What else? They could be straight activists. I mean, like I said, certain geographies are banning digital coins, and the future of the entire crypto space is uncertain, because these things, Bitcoin in particular, but all digital currencies, if you look at their core code, it tells the story of a future revolution and a new libertarian way of life. So governments and banks are slow to catch on, because the most dense people work in public administration, so they're not great at this thinking business. But Bitcoin has been around for more than 10 years now, and they're starting to put two and two together, and at a certain point they'll be like, hey, wait a minute, what's happening here? So if they catch wind of the fact that there's a technology out there which is very able to pull the rug from under their feet and basically take over the economy by devaluating their national currencies, they will immediately do everything within their power to shut it down. And the sad thing is, I mean, of course, in places with authoritarian forms of government, they'll have no problem imposing any kind of ban, but even what we refer to as democracies, they can be very abusive. So the only thing that can potentially stop a crypto ban is an educated public. People should understand the advantages of crypto coins and also understand why the state might want to ban them, so that when the state does attempt to ban them, there can be some meaningful pushback from the people. Otherwise, if things stay the way they are, because let's face it, most people can't be bothered to learn about cryptocurrencies. They just have this prejudice that it's too complicated for them to understand, and if countries wanted to right now to coordinate a worldwide ban on crypto, they could make the world swallow a narrative like they're dangerous because they're being used on the dark market or something like that. So anyway, that was a substantial tangent, but the point here is that crypto activism might be appreciated by the EOS electorate, which does want a crypto-centric future. Okay, moving on. Maybe you don't need to be an activist to get that sweet block producer money. Maybe you just need to pay for ads. Wouldn't it be sad if all you had to do in life to make money is to spend money? I think it would, but fortunately, that's generally not the case. We can see how much of a factor spending money is in this case, because the amount of backlinks that each candidate website has is directly influenced by the marketing budget that they have. Oh, if they run lots of ads, then their website will be linked all over the place. And I'll show you how to extract that data point in a second. It's very simple. What else can we factor into this analysis? And by the way, you come up with these features if you're somewhat familiar with the vertical. So you need to have a fair understanding of the needs of and the pains or the incentives that run the competitive landscape which you're analyzing. And the easiest way to get that is to talk directly to stakeholders. You can also read articles, watch keynotes. There's no shortage of resources for learning about any business sector, actually. Let's think about what else we can consider here. How about their social media presence? Things like what platforms they use, what type of engagement they get, how many followers they have. So the number of followers, for example, is fairly simple to get for each one. So let's put that in as a category. And also let's look at how much content they put out in the form of blog articles. Okay, there's another trend, or not even a trend, but it's a fashionable thing to have on your Block Producer website. This thing that you're eco-friendly or have a low carbon footprint. I do appreciate it. I mean, we all know how awful Bitcoin mining can be for the environment. So let's see how much the community cares about that. And of course the team. So if the founders have been involved in other crypto projects or have published scientific work, you know, that might work towards getting more votes. Let's try to quantify that as well. And lastly, I think let's do a very specific one. There's a thing called EOS mining, which when you first hear about it sounds like a contradiction in terms since there is no mining in EOS, but what some block producer candidates are doing is allowing people to delegate the vote through a proxy and then collect a share of the block rewards. Basically, they pay people to vote for them, but they don't call it that. They just they describe it as like a savings account. What they say is, if you let us hang on to your coins, yes, we will use the coins to vote for ourselves, but you get I don't know, 3% annual, or is it monthly? I think it might be monthly. Yeah, they even say delegated vote means mining. I don't think delegated vote means mining, but some block producers that apply this strategy are quite high up in the charts. So let's add this as a feature and see how much of a difference it makes in the grand scheme of things. Let's add all these columns to our data frame with a default value of 0, and let's check to see that it did that. Okay, so let's start filling in the data frame with actual values. Let's start with the backlinks. You're going to need the Google API client, so install that if you don't already have it in your environment, and then get an API key for custom search. So in your Google Cloud Console, activate the custom search API, enable it, make some credentials, or you can use your global credentials for the entire account if you're more of a rebel and you like living on the edge. Anyway, once you have the good stuff, let's build a query. And restrict the search so just you get only the last 14 days, because you want it to reflect the ongoing marketing budget, because the results of the election are ongoing, so the features should also be as up to date as possible. Maybe I didn't mention this, but on EOS people vote on a rolling basis, so there are no specific times when the election happens. Okay. You'll find the number of links in the search information field under total results. So yeah, let's print out something so that we see what it's doing, because it might be a while. Okay, so it's pulling some stuff in. but the websites don't seem to be referenced, with the exception of Bitfinex. Let's see, it looks like if we extend the time frame to 3 months. Okay, again the outlier is Bitfinex, whose website is actually the same as their well-known exchange, so it's not particularly indicative of the block producer activity. So this data point is not looking relevant. Let's not use it. There's not much more data that we can collect programmatically. I mean, we could design some smart crawlers and grab the data that way, but I feel like it's too experimental and the accuracy might be off. We could get the wrong data into the model. So let's just collect the data manually. So let me export this as a CSV and get it into Google Drive because I want more people to be able to work on it at the same time. I'll add description to each of the columns, explaining exactly how to go about getting that data point, because I want to get 1 or 2 virtual assistants to help me. And of course I'll go through an example or 2 with them for 1 or 2 rows to show them exactly how to go through the columns. But for some of these features, like the team score or crypto activism, they'll need to put in a subjective value. I mean, we could get the number of search results associated with the team members, but I think we can just let the person doing the data collection Google the team members and get a sense of the notoriety and put that as a score. The nice thing is it doesn't have to be contained within any particular scale. Like, it doesn't have to be from 1 to 10 or anything like that, as long as the relative proportions are maintained, because we'll normalize everything. So while the data is being collected, let's get our voters. We have our list of 100 block producers, and we have a list of features that we're ranking them on. As distinct from regular elections, this protocol here on EOS lets you know who voted for who, or whom. I know there's a whom somewhere, but I don't know where. Who voted for whom? Anyway, the candidates that an account picked are available as elements of an array and can be inspected through the API. So that means we can actually retrieve all the voting actions and use them in our analytics model. So we built a data frame with the producers, and now let's build a much larger one with the voters. For columns, we'll just go with account name, the amount that they're staking on their vote, and the candidates that they voted for. So let's call the EOS mainnet API again. First, we declare an empty string and make a counter variable. And the lower bound parameter means the name of the account at which it starts. Because this is in alphabetical order, we're going to start with that empty string as a lower bound, and it will continue until we have an account that starts with 6 consecutive Z or Z letters. So that way we pretty much get everything, but we will retrieve all the data in batches of 35,000 accounts so that we don't trigger a traffic limit on the API, and we also don't want to inadvertently DOS ourselves with a response. And let's add a condition to only look at the accounts which have something in their producers array. So once we found that, we can increment the counter to use it as the row number in the data frame, save the fields in variables, and then build the row. And let's just print out something here to check that it works, like the name of the last account. And also let's check how many rows it added after each call. So I hope this is fairly straightforward. Our program will just do a bunch of API calls in this while loop, and it will check 35,000 accounts on a call, and at the end of the call it prints out the number of accounts that it actually added, and then the last account name, and it continues to do so until it parses all accounts, which I think the number is a little over 1 million. Okay, I'm gonna take a break now and continue when the data collection is done, but you should definitely not take a break, because for you it will just seem like a second, because you have that biological nervous system at 300 hertz on a good day, whereas I am living in the computer and I can have multiple lifetimes in just one instant of yours. First of all, not all data points are available. I mean, not all block producers are making these data points available on their website. For the ones that we can find, we'll just put 0, since the voters can find them either, right? So they just don't count. Next thing we'll do is normalize the values. We'll just write a function to normalize the values, because we'll want to have these features quantified in the same scale across all the categories. So here's the function to do that. You can get it from Wikipedia. If you don't multiply it by anything, it will just return the value from 0 to 1. We'll multiply it by 9 to get it from 0 to 9. Okay, so right now we have the competitors broken down into features and assessed on each individual feature. We also know the choices of all voters. So let's do this. For each voter, we take the array of candidates that they have and we convert it into a set of preferences. Does that make sense? So think about it like this. Let's say we have a voter who just picked one candidate. That would mean that the features of that candidate, okay, the ones that we mapped out and ranked, are what the voter prefers. So we can add the same categories to the voter's data frame, and for each account we'll calculate the preferences by summing the feature scores of all the candidates that they voted for. And the way that we can tell if the features we picked are relevant is if we get similar scores for most of the candidates in a voter's array. Otherwise, if they pick one candidate from India and another from Cayman Islands, for example, it's obvious that that voter doesn't care about jurisdiction friendliness. And we can just discard that feature for that individual voter. So we're going to have to do this for over 40,000 accounts. We should use multiple processes in parallel. Otherwise, this will take a few days. And because IPython doesn't allow multiple processes, we're just gonna have to script this task in a separate file. So let's bring in our two data frames and add the column of the categories to the voters. And let's define our function for adding the preferences. Each one will take in a starting point because it will start at a different point in the data frame. So this is the method that will run on each of the workers. That will have 50 workers in parallel. Let's say 50, I guess. So if we have 50, then we will run each one for exactly 863 rows. And how many we have left over? Okay, we're not even going to bother with those. So each process will get 863 rows. And for each row, let's go ahead and add the data points that we already have. And iterate through the categories, reset an int variable here because we'll use that to sum up all the values in this category. And now we'll iterate again through the array of producers for this voter. So the producers that this voter picked. Trouble is that this is not saved as an array, it's saved as a string, but the string is formatted as an array. So we'll just need to separate it at the apostrophe and then make a list out of every other element. And because we have over 1,000 block producers, I don't know how many there are, but I know there are more than the 100 that we collected. So we'll need to make sure that whoever the voter picked is in our list here. And then we do a cross-reference using the account name of the block producer, and we increment the variable with whatever the score the producer had in that category. It's simple, right? You can see that there are loops within loops, which will take a long time on a single execution thread, or process rather. So let's just fill in the appropriate cell in the data frame with the value that we got, and then at the end, after all the loops, we export the file. Now, the main method. We'll need an array to store our processes. I apologize for that. Okay, counter, that's always good. Let's make a counter, and then a data frame with the same columns as the one with the voters, and for each of the 50 processes, we'll add it to our list, and then we'll have it run the method and pass it the starting point, and then the data frame, and of course the starting point needs to be incremented before moving to the next process. Let's get the data frame in the method here as well, and let's start all of them, and let's then wait for all of them to finish, and then we'll add all the data frames before merging them. Let's add them to a list, and another counter here, increment that, join the data frames in a single file that we can export. So that should be everything. Let's also print some stuff to track how it's going, say program start and program end, and once every 25 rows, let's print out the actual row, I think. Yeah. Okay, let's run it. Yeah, okay, it seems to work. I estimate it will take between 10 minutes and 1 hour. Let's just check that it did start the workers. Yep. Okay. So that went great, and you can see that we now have all the files, including the big one. So let's get back to the Jupyter file and import our data frame. We can actually start plotting stuff at this point. I don't mean like assassinating the emperor to take over the, you know what I mean. We can visualize the data. Assassin. Whenever there's a word that has a repetitive phonetic structure, I intentionally exaggerate that repetition because I think it's funny, but it's not funny. I know that right after I do it, but before I do it, I'm like, man, this is gonna be so funny. And it's a problem. Anyway, to plot the preferences, we'll need a dictionary. Then iterating through our categories, we'll get so let's normalize we'll get the normalized values that will be in the same range. Remember, we wrote that function, this one here. So we'll first need to pass in the value that will be the mean average of this feature, then the range. This will give us a list of preferences for the entire electorate, but it will not it's not weighted by the amount that is staked on each vote. This is more like if every vote had equal power, which is not the case, because the more tokens you stake on a vote, the more it counts towards the result. So let's actually represent these features in the way that they actually work. We'll add in another set of columns for the voters for the weighted preferences, and we'll multiply the preferences. Each preference will multiply it with the amount that they stake on the vote. And this should go fairly quickly because it's just one multiplication. Okay, now another dictionary for the weighted preferences, also normalized. Let's actually consolidate the three features that make up the infrastructure, because no one cares about the storage individually. So let's just make a single feature that is the average of these three for both weighted and non-weighted sets of data. And now let's visualize two pie charts. And by the way, the difference in aspect that we see between these two charts is exactly the difference between a democracy and an oligarchy. So that's cool. We got a sense of what matters more to the community. So if we want to potentially submit our candidacy, we might know what to spend our resources on. But let's maybe go a step further and actually get precise estimation of the effort it would take to become a block producer. And also what would be the most efficient marketing assets. So what to promote and which stakeholders or to which segment of the electorate should we promote our assets to? So that's a lot of questions, but we can answer all of them with a relatively simple nearest neighbors model. But first, let's take this into Google Colab because this notebook doesn't support forms. So open up a new Colab notebook, connect it to your Google Drive, upload the data frames there. I mean the CSV files, then get them into the notebook as data frames and maybe copy some of the last cells from the local Jupyter file to extract the preferences, normalize the plot, and it should run just the same. Now, let's make a form that takes the user input for all these features. So we have 7 sliders, then 3 fields where we input the value manually for the individual components of the server infrastructure and 2 Boolean values for staking and 0 emissions. So basically we'll simulate with this how the electorate would react to different configurations, meaning who would vote for us and also how high would we get? What is the level of success we would get with different configurations? So first we write a function that takes in the 2 sets of coordinates and returns the Euclidean distance in a multidimensional, in this case 12-dimensional space. And one thing that we want to do is we only want to increase the distance when our score on a particular feature is lower than the preference of the voter, because if it's higher, obviously we qualify, so we don't need to increase the distance. We assume that they care for the features being a minimum value, not necessarily being at that value, right? If we have a higher score, we just set the value as being the same, but if we're lower, then we do the square root of the sums of the squared differences, okay? This is the formula here. Now let's also define a success function that takes in a set of feature scores and a tolerance level. We'll need the total amount staked on us from voters, and we'll also need a list of accounts that are likely to vote for us based on those scores. And then so going through the list of voters, let's make a list of features for each voter and get the distance between our scores and the voters' preferences. If the distance is smaller than whatever tolerance we set, then let's add this to our list of voters, and then their staked amount to our name, but not all of it, because it's unlikely that they'll drop all of their candidates and just have us as a single choice. So we'll need to divide this number by the length of the producers array, but this is again the problem that we had before. We need to make the array from the string because it's still formatted as a string. Now this will be the starting point of the simulation where we set the input variables. Let's store the results in a variable. So that will be an array with the first element representing the total amount and the second, the voters who picked for our fictitious candidate. Let's print out what we got and from how many votes. And let's also see the position that we got by comparing our staked amount with that of the BPs, with what the BPs have. Okay, we can see that we got this amount staked from a total of 14,883 voters, and you can just mix and match, especially if you have some fixed resources that you can use. You can figure out how to pair them for best results. And we can also, if you can associate the account names with some other information about the voters, you know where to reach them maybe, and you know exactly which assets you need to make known to them, because you already know what they react positively to. So yeah, this is a basic framework for scientific competitive analysis, and you can get more crazy with third-party APIs to collect the data or integrate some more advanced predictions. The thing is, even though this is a case study, I mean, it's a specific example, the basic principle can be applied to basically any competitive analysis. Let's recap the steps. First, make a list of competitors or find a ready-made one. The list should include how much market share each of them are getting. This is important. Next, discover the features that matter in the specific vertical that you're analyzing, but from the end user's perspective. Don't classify the features by anything else than user stories. If they're a learning management system, for example, that uses facial recognition to identify the student, the potential feature will arise from the reason why the student needs to be identified, not the accuracy or the type of technology that they're using. In this case, it might be something like preventing students from cheating on tests. And then go ahead and rate the competitor on how well it addresses that need. Once you have the relevant features, start gathering the data for as many competitors as you can find. But make sure you get the ones with the biggest market share, because those are the ones you want to analyze primarily. Then try to estimate the effort associated with scoring an average and a high value for each of the features. This can and will be specific to the resources you already own, if you're doing this from the perspective of a newly founded competitor. Find the top customers for the individual competitors. This may or may not be possible. I know that in the enterprise space, the top customers are usually listed front and center for everyone to see, but that's not always the case. Anyway, if you can find the customers, this analysis will also provide you with some solid leads for sales. Then simulate different feature configurations to get an estimate of market share, as well as a list of the most likely customers that you would get with that configuration of features. And that's everything. I'll put a link to the code in the description, and if you're interested in this specific competitive analysis that we did for the EOS Block Producers, I made a web app which you can interact with easier because it has a front end, but it has basically the same logic, so except it's just written in Java. So you can see the scores for individual block producers. You can go to the second tab and see the preferences for the entire electorate or some of the voters. You can even do one at a time. And of course you can create the mock candidates with different features and different scores on features and see how the voters would react. So I'll link that as well. But yeah, if you're really into EOS, maybe check out my amendment proposal for the constitution, which is called performance staking. I'll link that as well. And yeah, thanks for watching. Goodbye.